Number 12 in OPENSTAX. So we want to calculate the molar mass, and so that's for 1 mole. So these are going to have units of grams per mole. Now what you want to do is refer to the average atomic masses for the different elements that I use from ptable.com. So HF has, for example, 1 hydrogen, and hydrogen weighs 1.008, and so fluorine, we have one of those, and it's 18.998. And then we want to add these two numbers up together, excuse me, and what we'll get is the total mass of the molecule, and this is what we call the molar mass, and it has units of grams per mole. So what we get is 20.0078 grams per mole. Okay, so that's for the hydrogen fluoride molecule. Now ammonia has 1 nitrogen and 3 hydrogens. So in a similar fashion, we would, work on that. So ammonia, we have a nitrogen. One of those weighs 14.007, and we only have one. And we have hydrogen, and we have 3 of those, so we need to multiply the number we find in the periodic table by 3. Okay, and then as before, we add these up. We take the sum of all of the different types of atoms, 007 plus 3.024, and we would get, in this case, 17.031 grams per mole. Okay, let's do HNO3. So HNO3 has several different atoms in there. We've got a hydrogen, a nitrogen, and we have an oxygen. So hydrogen, remember, has a average atomic mass of 1.008. Nitrogen, we just have one of them in the formula. Now you don't have to multiply these by 1, but I'm just trying to explain it super careful here. Now we have 3 oxygens, so definitely this one, we need to multiply 15.999 by 3. Okay, and we get 47.997. The last step always is to add up the total from all of these to get your molar mass. And I'm getting 63.012 grams per mole. Let's do silver sulfate. It doesn't matter if your substance is a molecule or an ionic substance with a formula unit. We can find the molar mass just from the formula. So we're calculating the formula weights here. So we've got several different elements that we might be less familiar with. We've got silver, we have sulfur, and we have oxygen. Now we have 2 silver, and you can hunt around that for that on your periodic table. And that has a weight of 107.87. Okay. And we need to multiply that by 2 because the formula has 2 silvers in it. Okay, and so we get 215.74. Okay, silver is a pretty heavy metal. Sulfur is one of those, 32.06. Oxygen, we have 4 of them, so watch out for the 4. We have 15.999 in my ptable.com periodic table. Multiply that guy by 4. Okay. And the final step is to add these guys up. Okay. and we get 311.796 grams per mole. Okay. Next, we have boric acid. Before jumping into this, I just want to make sure that you know how to deal with the subscripts in this formula. I'm putting in the ones just to help explain this. Now, boron is outside of the parentheses, so we just have one of those. And boron, it's number 5 on the periodic table, has an average atomic mass of 10.81. Okay, so nothing fancy there. Now, oxygen is inside the parentheses, and we have a 3 outside the parentheses. So that's like taking 1 times 3. So there's 3 oxygens in this formula, and 15.999 are the usual atomic mass of oxygen. Gives us 47.997. Now hydrogen is also within the parentheses, so that's also like 3 hydrogens. So there are 3 times 1.008, and that's 3.024. And again, we want to add up all of these guys here. Okay, and we'll write the final answer in green here so it's easy to find. 10.81 plus 47.997 plus 3.024. Okay, so definitely watch out for those parentheses. And this would be the molar mass of boric acid. Thanks for watching, and please subscribe.